A shattered crystal vase on a stone floor, its fragments scattered like falling stars, spontaneously gathering themselves. Shard by shard, they leap into the air, rejoining with a faint chime, until the vessel stands whole again, pristine and perfect. A distant dying star, having exhausted its final reserves of hydrogen, suddenly contracts, its cold ashes reigniting in a brilliant flash, reversing its own death to burn anew. This is a universe of miracles, a cosmos where time can be undone, where decay is merely a temporary state before an inevitable return to order. It is a beautiful, elegant, and logical dream. And it is a universe that is fundamentally, unequivocally forbidden. Our reality operates under a different, more tyrannical jurisdiction. From the instant of the Big Bang, a silent, unwritten law was woven into the fabric of space-time, a dictate that governs every particle, every star, every galaxy, every living cell. It is a law that points in only one direction, away from perfection, away from order, and towards an ultimate, irreversible state of dissolution. This isn't a subtle philosophical concept. It is the most visceral and observable truth of our existence. Leave a magnificent cathedral to the elements, and it will not become more magnificent. It will crumble. Stone by stone, it succumbs to wind and rain, its intricate carvings eroding into dust, its structure surrendering to gravity. The information encoded in its design is lost, scattered, and dissipated. Observe a simple cup of hot coffee left on a desk. The heat, a concentration of energetic, fast-moving molecules, does not remain confined to the cup. It inevitably bleeds out into the cooler, less energetic air of the room, spreading its energy until a state of bland equilibrium is reached. The system, coffee, cup, and room, becomes more uniform, more generic, more disordered. There are no exceptions. From the grandest cosmic scales to the most mundane daily events, we witness the signature of this relentless cosmic bias. It is the reason our memories are of the past and not the future, the reason we are born young and grow old, the reason stars burn out and empires fall. This isn't just about decay, it is about the very nature of probability playing out on a cosmic scale. The universe does not possess a malevolent will to create chaos. It doesn't want things to fall apart. The truth is far more profound and mathematical. This cosmic law is rooted in statistics. Imagine a simple box divided in two, with a handful of gas molecules all starting on the left side. This is a state of relative order. If we remove the divider, what happens? The molecules will naturally spread out to fill the entire box. They do this not because of a mysterious force pushing them apart, but because the number of possible positions and velocities for the molecules, what physicists call microstates, is astronomically higher when they are spread throughout the entire box, compared to when they are crammed into one half. There is only one way for them all to be on the left, but there are googles upon googles of ways for them to be distributed evenly. The universe, at every moment, is simply moving towards the most probable state. A perfectly assembled sandcastle is a single, highly improbable arrangement of grains. A scattered pile of sand represents a near infinite number of possible arrangements. The waves and wind are not malicious. They are agents of probability, nudging the system towards a state with more options, more disorder. This principle was born with time itself. In the first moments after the Big Bang, the universe was in a state of almost incomprehensible order. It was incredibly hot, incredibly dense, and astonishingly uniform. This low entropy state was like a perfectly wound cosmic clock. The entire 13.8 billion year history of our universe, the formation of the first atoms, the gravitational collapse of gas clouds into the first stars, the swirling of those stars into majestic spiral galaxies, the forging of heavy elements in supernova explosions, the birth of planets, and the rise of life is the story of that clock unwinding. Every complex structure we see is a temporary eddy, a beautiful, fleeting pattern formed as the universe's initial energy disperses and its initial order degrades. Life itself is the most profound example. A living organism is an island of staggering complexity, a biochemical machine that maintains its intricate order by consuming ordered energy from its environment and expelling disordered waste back into the cosmos. We are localized pockets of defiance, but our very existence accelerates the universe's overall descent into chaos. We are the magnificent temporary structures built by the same law that guarantees our eventual demolition. What is this invisible architect of ruin? What is the name of this cosmic law that dictates everything from a cooling star to a forgotten memory? And if its ultimate goal is dissolution, why did it first build a universe so magnificent? From that profound cosmic question emerges the universe's most unyielding dictate. The architect of ruin, the engine of all change, is not a metaphysical concept, but a pillar of physics, first articulated by scientists like Rudolf Clausius and Ludwig Boltzmann. It is the second law of thermodynamics. This is not just another rule in a textbook, it is the very reason we perceive a difference between the past and the future. It is the source of the unbreakable arrow of time. At the heart of this law is a single, powerful concept, entropy. While often described simply as disorder, entropy is more precisely a measure of the number of ways a system's constituent parts can be arranged without changing its overall appearance. It is a measure of hidden information, of microscopic possibilities. A perfectly ordered crystal has low entropy because its atoms are locked in a rigid, predictable lattice. There are very few ways to arrange them to still form that same perfect crystal. A gas, by contrast, has high entropy because its atoms can be in a near infinite number of different positions and moving at different speeds while still just looking like a gas in a box. The second law states that in any isolated system, entropy will, on average, always increase or stay the same. It never, ever goes down. This is not a force, but a brutal statement of probability. When you drop a ceramic cup, it shatters. Why? The fundamental laws governing the atoms in that cup, electromagnetism, the nuclear forces, are all time-symmetric. A video of two atoms colliding and bouncing off each other looks just as valid played forwards or backwards. So why doesn't the shattered cup ever reassemble itself? The answer lies in the staggering statistical imbalance between order and disorder. The single intact cup represents one macroscopic state corresponding to a relatively small number of valid microscopic arrangements of its atoms. The shattered pieces on the floor represent a different macroscopic state, but one that corresponds to a vastly, unimaginably larger number of microscopic arrangements. The pieces can be in countless positions, orientations, and thermal states. For the cup to reassemble, every single one of its trillions of atoms and all the atoms in the surrounding floor and air would have to move with an impossibly precise, coordinated velocity to return to their original low entropy configuration. It's not physically impossible, just statistically miraculous to the point of being absurd. The odds are so vanishingly small that if you waited the entire age of the universe, you would never see it happen. The universe always flows towards the states with the most options, the highest probability. It's why you can't unscramble an egg, why cream mixes into coffee but never unmixes, and why every star is a one-way engine converting the elegant order of matter into the chaotic disorder of light and heat. This law explains not just our future, but also our past. The fact that the universe today is not a featureless uniform soup of particles tells us that it must have started in an even lower entropy state. That initial highly ordered condition of the Big Bang is the ultimate source of all the order we see. The slow, inexorable increase in entropy from that starting point is what drives every process in the cosmos. Every star that shines, every planet that forms, every thought that flickers through your brain is powered by this cosmic unwinding, this flow of energy from a more ordered state to a less ordered one. But if this law is absolute, what is the end point of this journey? If entropy must always increase, where is it all going? This leads to a chilling yet scientifically grounded vision of the ultimate future, the heat death of the universe. In this distant future, trillions upon trillions of years from now, all the stars will have burned out. All matter will have been consumed by black holes, and those black holes themselves will have slowly evaporated away into a faint mist of particles through Hawking radiation. The universe will have expanded to such a colossal size that the remaining particles are light years apart. All energy will be perfectly and evenly distributed. There will be no temperature differences, no gradients, no concentrations of order. The cosmos will be a vast, cold, dark, and featureless void in a state of maximum entropy. Without energy gradients, no work can be done. No change is possible. Time, which is defined by the progression of entropy, will effectively lose its meaning. The cosmic clock will have fully unwound, and it will tick no more. We and all the complexity we represent are the beautiful, intricate patterns the universe forms on its one-way journey to this final silent equilibrium. Our existence is not a fight against this law, but a fleeting, glorious consequence of it. The ultimate question then is not how we escape our fate, but what meaning we create within the final, precious window that the laws of physics have granted us.